the purpose of this presentation is to discuss security defenses and why we need to be testing our security defenses. So there will be basically two questions I will try to answer. First of all, do we need to test our defenses? We know that security is becoming better. We're investing a lot more money in enforcing security policies and to prevent attacks from happening. So is there any point in investing any more money in testing whether these defenses are working? And the next question is, how can penetration testing fit within this problem? How can it help to address this problem? So, to get you out of your misery, the answer is yes to both of them. The presentation will go through three different sections. So, first of all, why do we need to test our defenses? How the different phases of penetration testing can help us improve our security, and then some general guidelines how to strengthen defenses. Okay, so we did say, I did say earlier that security is getting better, and we can see that from the security surveys that are around. Based on the information security breaches survey, which was published last year at InfoSecurity, they found that the average cost of the worst security breach of respondents was about 15K to 30K for small businesses, and 100K to 250K for large organizations. Now these costs are less than they used to be, so we can definitely say that the investments on security are working, and we are becoming a lot better. But nonetheless, if you pair these amounts with the number of severe incidents that were experienced, and these were about 33 breaches in small organizations and 134 breaches in larger organizations, then we can see that the overall cost is still significant. So for smaller organizations, that would be 500K to 1 million, about 500K to 1 million, and for larger organizations, that could be 15 million to 33 million overall cost in a year. So it's still a significant amount. There are obviously investing some money at this stage in testing whether security works. And the main approach is we can see that external penetration testing and internal penetration testing are quite popular. By far the most popular method would be internal and external audits, which we will see in a minute. And also email and web monitoring are quite popular as well. So what is penetration testing and how can it help? The basic emphasis here is they are legitimate and authorized attempts to test and improve security defenses by identifying and exploiting vulnerable systems. Emphasis there is on, first of all, determining the business risk, the impact of a vulnerability, of an intrusion. Another key word here is in a controlled, professional, ethical manner. Admittedly, nobody wants to hire a hacker in order to test the security of their systems, and that's why, as part of penetration testing, it's really key that this testing happens in a controlled, professional, and ethical manner. Okay? And so the purpose of penetration testing is to help organizations improve their security defense, identify where problems might lie, and help them to improve them. Penetration testing should take place regularly anyway, but it is especially important when new services, new locations, significant configuration changes take place, and so when you introduce new equipment, for example, new policies and so on, in new office locations, all these are really important stages at which you would be strongly encouraged to use penetration testing. So you did see in the previous graph, which was from the CSI FBI security survey, by the way, on what are the techniques that are being used to test security defenses. We can basically think of two main alternatives to penetration testing. That would be vulnerability assessment and security audits. You can also use intrusion detection systems or web email monitoring as a way to see when existing defenses fail, and that's definitely one way to go. Or you can use configuration and architectural review to look through the existing offering, the existing configurations you have, the processes, the policies, and make sure that you're following the right procedures. But the two main alternatives to penetration testing will be vulnerability assessment and security audits. In a way, you could say that vulnerability assessment is a subset of penetration testing. The aim of vulnerability assessment is to use tools to go through the either actively query systems or be installed on these systems, get the versions of the software that is being installed, identify possible vulnerabilities in that software. The characteristic of vulnerability assessment is that it stops there at identifying vulnerabilities, whereas penetration testing goes even further in exploiting these vulnerabilities. And if you ask yourself, why do we need to exploit these vulnerabilities, the best answer would be that you need to understand the impact of a vulnerability. If there was a survey done recently where they identified millions of public-facing devices in organizations, printers, cameras, devices, and so on. If you tell the manager or the CEO or whatever of an organization that this is a vulnerability in the system, they will say, so what? What does it matter if a printer is accessible externally? But if you show them that if you use this printer as a pivot point to go into other systems deeper within the organization, and then based on that you can even get access to the customer database where all the details of the organization's customers are held, then of course they will be able to take notice and they will be able to understand what the impact of that small vulnerability is. And so you could say, vulnerability assessment is definitely part of penetration testing. Security audits, on the other hand, they are more standardized processes. They follow a rigorous set of criteria, procedure, checklist to ensure that there is compliance to a security policy. They involve quite a lot of interviews with key personnel in their organization to make sure that they follow the procedures that they should. And in fact, penetration testing is a subset of security audits because it is often used as part of a security audit in order to test the findings from these interviews and the review. So why do we need penetration testing? As I said previously, it does show the real-life impact of an intrusion, and that is the basic advantage, really. It is a lot easier to communicate this to management if you can tell them exactly what this particular vulnerability means. Also, another advantage is that it allows you to see the security of your systems or the defenses you have from the perspective of an attacker and what they might know. And this is something that existing or other alternatives do not really offer. And so, in a way, a penetration tester needs to have two hats, or the mindset of a penetration tester needs to be, first of all, a professional. They need to operate in this professional, regulated, legitimate manner, but at the same time, they also need to think like attackers. and they need to find access points into an organization with the mindset of an attacker. And finally, another advantage that you might consider is the fact that it's more transparent to the personnel of the organization. We said that penetration testing can be used as part of an audit, but it doesn't have to be. And it usually requires much less time from the organization's personnel. It works more transparently. So it doesn't require so many in-depth interviews, audits, and so on. And going back to the point where you look at the real-life conditions of an organization, when you're doing a security audit, everybody puts their best suit and they go to the interview and they hail all the security defenses they have and how secure the systems are. Nobody really wants to give the wrong impression, of course. But in a penetration testing, you actually get to test the real-life conditions, and there is a great value in understanding, of course, the results of a penetration test as well. So what do these results mean? If you are engaged in a project and you just take for granted only the systems that the customer wants to give you, only a very small subset of the systems, then of course you need to be aware of the implications the result of the penetration testing is going to have. So if you only test the control amount of systems that they want you to, a significantly smaller subset of the organization, then of course the chances of uncovering any real problems would be less. So the next point would be to see how the different penetration testing phases can help us test the security of our defenses and help us improve security. Okay, so the first stage of any penetration testing project is the planning and scoping, and this is where you set the requirements, kind of decide on all the parameters that are accepted as part of the penetration testing project, what is accepted, what isn't accepted, and based on these parameters you sign up a contract which is kind of the get out of jail card for penetration testing, which says these activities, these are the activities that are authorized and so on, and based on that you will use that to inform all the other stages of the project, which include reconnaissance, scanning, exploitation, and post-exploitation. Reconnaissance is when you use public-facing information available to everyone to profile the organization and help you to get a picture, a clearer picture of the services they might have, the people that are involved, and so on. Then you use this information to inform all the later stages of the project. Then you use scanning, where you are trying to identify access points, vulnerabilities, access points within the network, and there you use more specialized tools for that. And then finally you've got exploitation and post-exploitation, which are ways in which you exploit the vulnerabilities you discover, and you conduct further activities to either show the impact of the vulnerability. Now, the main differences between a penetration testing project and a real intrusion would be in the exploitation and more specifically in the post-exploitation phase. An attacker is not going to politely ask, so what is allowed after I exploit the systems? They will just do whatever they want. Whereas a penetration tester, they have to work under the specified contract during the planning and the scoping stage. Okay. Okay, so the planning stage basically involves setting these parameters, the rules of engagement, what is allowed and what isn't as part of the project. First of all, contact information. If anything, should anything go wrong, who do you need to call? So that will be the key point of contact from the organization and the pen testing team. How data should be exchanged, what encryption standards should be used in order to conceal, to preserve the confidentiality of the data and not to have information leaks. How the teams should be communicating, debriefed. For example, it's quite common that you would have daily debriefs with the organization to tell them exactly what you found, the findings of the day, and to decide on a course of action for the following steps. So the initial planning and scoping phase does set the parameters, but still, nonetheless, it is very useful to have this exchange of information to achieve, well, better results, really. So there is also the other things that you would agree would be the time frame in which the testing will happen, the start date and end date. Having said that, what it also needs to be avoided is to give the exact date of the testing, because obviously that means that everybody will be prepared, they will have patched all the systems, they know that will be tested, and no problems will be discovered and everything will be wonderful, but it will not reflect the actual picture of the organization. Also, another aspect that will be covered will be what is the acceptable times for testing. For example, it might be possible to do it only at night time, not at the busiest hours where you don't want any business to be impacted, which is fair enough. So all of these need to be sorted, need to be decided and agreed upon. Also, whether you want to have black posting or crystal box testing will need to be decided. What that means, black box testing means you are doing a test, a penetration test, knowing nothing about the organization, any IP addresses or any information. No information will be provided. And of course, every single customer wants a black box testing. Crystal box is when you give some information available. In reality, most penetration tests start as a black box, and then pretty soon the people realize that it is way more efficient to use a crystal box testing technique instead. Why? Because this kind of information is publicly available. Quite a lot of information is publicly available, and I will show you in a minute how much information you can discover. In order to discover this information, it takes time, and so quite often it will be a lot more efficient to give the penetration tester all this information, which they can recover themselves anyway, but they will obviously charge you for the time they use in order to discover this information. And so to use their services mainly for the other stages. So in reality, it will be in most cases, it will be crystal box testing. Another thing is that penetration or attackers will usually have botnets that will be engaged in this reconnaissance and information gathering techniques. So they will have plenty of time available to them and plenty of resources, whereas penetration testers will not necessarily. And so in reality, as we said, we usually go for a crystal box testing option. Most importantly, what needs to be decided in the rules of engagement is what is acceptable after compromise. There are quite a few risks, obviously, after you compromise the security of your system, and we will discuss them in a minute. Leak of information, of sensitive information, is one of them. Changing the configuration of the system is another. There is hundreds, thousands of tools available to penetration testers and attackers at the same time. And they can use lots of these tools. The question is, are they allowed to do this, or will they need to resort to simple commands in order to go into to progress the following stages of a pen test. So all of these parameters need to be decided and agreed upon in the rules of engagement. Another sticking point that would definitely need to be discussed is how the results will be treated. So especially if you're going for external penetration testing, but even in internal systems, if you leave the results of a penetration test in your system, then somebody could subsequently try and get this information, and therefore all your vulnerabilities have leaked, and maybe confidential data could have leaked. What is acceptable to include in the report, in the penetration tester report? Again, that is an important issue. And why all of these are important is because obviously the purpose of a penetration test is to show the vulnerabilities, the impact of these vulnerabilities, but in reality not to expose the security of the organization, only to the intended parties. So, as part of the scoping, you basically identify which systems, what services you need to be tested, what services you definitely want to avoid, you don't want to touch. So all of this needs to be identified. Now, usually a customer will tell you, "Oh, I want you to test everything, you know, all my 10,000 or systems or whatever." Now, if you think about it, the mathematics of doing that are very, it's going to be very costly, very expensive. And so understanding or deciding what is a representative sample will be very important. Another issue that needs to be considered is any third-party equipment. If you're using systems ISPs, is it okay to test the routers or the devices of the ISPs or cloud services? Or if you outsource the security of your devices, is it okay to be testing these devices that are being managed by third parties? So it is important to understand all of these parameters and to make sure that you operate in a legal manner. And so usually, if you have to test any third-party equipment, you do need the get-out-of-jail card from them as well. Another issue is whether you want to test on a live system, production system, or whether you want to just take a clone of that system and test it offline, where even if you break something, it doesn't really matter. So if possible, of course, the second option would be a lot better, but in some cases it's not possible. And so you do need to test on a production system. So you need to be very wary of the risks. So for example, if you're testing on a production system, you might not want to use any dangerous exploits that might break it or cause a DOS. And so you might want to have a parameter there to use only safe exploits, and so on. Well, if you, in terms of whether you have internal or external testing, that of course means whether you should be allowed within the organization and test there, or whether you should be somewhere remotely, and that of course depends on the organization and what they would prefer. Whether social engineering, dangerous exploits or DOS attacks should be allowed, again, all of these depend on the requirements of an organization. But they can all be covered as part of the project. So after the parameters are decided and you know exactly what is allowed, what is within the scope of your project and what isn't, then a penetration tester will go through the 4 different stages of the project. So the initial stage is reconnaissance. That takes about 20% of the pen tester's time. Even if you go for a crystal box testing, it's still worth investing some time in the reconnaissance phase, mainly because you can uncover quite a lot of information that can be really useful in the later stages. So things you might be looking for would be inventory of possible targets, the servers, all the servers, infrastructure, any filtering devices that may be there, Employees available in the organization, public facing employees, the culture within the organization, any terminology, any technical projects, and so on that are being used, or the lingo of the organization, the culture of the organization, of course. And so for that, you're basically retrieving publicly facing information. So you're using DNS lookups in order to identify important servers of the organization, who is, in order to get the people that are responsible for the IT infrastructure. You're also crawling with the website of the organization in order to identify key personnel, terms used, projects within the organization, and so on. Google searching is really useful. It's a very good tool in identifying any sensitive information that might be there, software that might be running, and so on. Any documents, PDF files that are used, again, they could be very useful at giving you this early insight. So using the web is a great tool, apart from DNS, lookups and quiz and so on, where you can crawl the website to look at employees' email addresses. Usually, sometimes, quite often, organizations use the email address that are very similar or a permutation of the usernames in that organization. So having email addresses of people within the organization publicly facing could give you insights into the user address policies. Office locations, job postings, especially if they provide information about technologies that are being used in the organization. You can also go back in time and see previous job postings and previous projects in the organization by using tools like the Wayback Machine, which give you snapshots of a website in the past. Also, if you recover any metadata, any documents, PDF files, doc, Excel, PowerPoint, and so on, JPEG images from the website, you can analyze them for metadata and see what kind of information you can get. So basically, you are using any public-facing information to put all the pieces together. And you don't have to do all of this by hand. You can just use automated tools to do it. So this is an example of what information you can recover from metadata. These are two, so on the right here, where you can see the picture, that's just a picture I analyzed with EXIF tool. And that showed me the camera that was used to take this photo, the model, which I could then use as information to probe for any public-facing cameras that might be in this organization. Similarly, on the left is just a text, testing file that I analyzed, and that shows you the application that was used to create this document. So that was Microsoft Office for Mac. There it is. And also the version, the operating system, and the user that was used in order to make this document. So I was able to recover quite a lot of information. Now, how would I use this information later on? If I wanted to target a client, then I would be able to take this information. Well, I would know the user, Maria Papadaki. Then I will show you in a minute how you can find more information about a person. But also, I would know the client software, Microsoft Office for Mac, that this person is using, and I would be able to use it in a client-side exploit, for example. So you don't have to do all of this groundwork by hand. There are lots of tools that allow you to automate this process. What I'm showing you here is Maltego, which is a reconnaissance tool that allows people to just put everything together. So with a click of a button, you can just give them a DNS address or an IP address, and they will be able to find all the other servers in that organization. They will tell you who is responsible, so they will build a diagram of all those systems. You can also add users in there, and it's able to go to their social networking sites, identify all the posts, all the feeds that they are using, and you can just put all of this information together to build a really clear picture of the organization and gather a lot of intelligence as a result. There are also, I mean, what you see here on the left, that is just a diagram of the systems, the IP addresses that it was able to recover from an organization. What is quite interesting is on the right hand, which is the Twitter posts of a particular employee that they managed to profile. And you can see in all these posts the projects that they are discussing and some of the problems they're encountering in their code and so on. All of this information is really, really valuable. But apart from that, apart from Altego, another tool is Tradis, which allows you to feed in to it the output from different tools. So if you use Nmap, for example, to scan a network, you can import the results into that. Then you can feed these results into Nessus and to identify vulnerabilities. These results again can be fed into other tools, and so it automates the process to a significant amount, and it's a lot easier than we might think. So if you think that every single item isolated means really nothing, but if you put everything together, then you get a lot more, a much clearer picture of what is happening. So another. The next phase, after you get this initial reconnaissance, is to use scanning tools, and this is actively targeting, probing the organization to find network sweeps, network traces, to see exactly the topology of the network. You're also using port scans in order to identify open ports within these systems. You use OS fingerprinting to identify the operating system of these systems, the versions, and version scans to identify the versions of applications, and this is especially important for misidentified ports, so services that are running in the wrong ports, not the standard ports. And finally, after you identify potential systems, you run vulnerability scans to test whether vulnerabilities are present in these systems. We did talk about network traces. A really good tool for the network scanning phase would be Nmap, and that has been optimized for large-scale scans. And it is really good at giving you this clear picture of the network. One feature is the network trace, which it does trace routes, and that differs hugely from the Windows and Unix trace routes in the sense that it uses decreasing TTLs rather than increasing TTLs. So Windows and Unix trace routes, they discover firstly the first hop, the second hop, up until it goes to the last hop of the destination. What Nmap does is it uses decreasing TTL, so it discovers the last hop, the one before last, up until it goes to the first hop. And that looks very inefficient if you think about it for one or two hosts, but if you think large scale is really, really efficient, because as soon as it discovers a hop, a node that it already knows about, it stops the tracing. So here, for example, we can see that, say if you want to go to youtube.com, as soon as it discovers a node that it already knows about, it has already searched before, it will just stop, and that is very efficient. In network scanning, port scanning, it is really important to make every single packet count, because it takes about 1 second for a computer to send a packet. And so it is really important to make sure that you are using it the most optimal way. Now, also there are options like layer 4 traceroute, web-based traceroute services that you're able to bypass, to use and bypass any filtering mechanisms that might be in organizations. Okay, so again, with port scans, which is the next step, the idea is that you will identify any open ports in the network, and you need to understand the parameters and the differences between TCP and UDP ports. With TCP, it's a lot easier to scan. With UDP, not so much, because the problem is you can't really tell exactly for sure if a UDP port is open or not. The main reason is because UDP doesn't have an inbuilt response. If there is application running on that port, it will respond, but otherwise the port could well be open and no application running. So it is a lot more difficult to understand, and so you need to have, when you're querying for UDP ports, you need to have the right queries to make sure you get the responses that you want. But similarly, you need to think of the mathematics behind a port scan as well. Nmap has gears in which you can scan. So you can go with a slow mode, which is more likely to evade detection mechanisms, or you can go with a, I don't know, the crazy mode or intense mode, whatever they call it, which sends, you know, an influx of packets at the same time. And so you can change the speed, but also it has the ability to test only the top ports. So they scanned the entire network and they found the most popular ports that are being used inside and behind, outside and inside the firewall. And so you can use a subset of the ports, the most commonly used ports, which are obviously a great help when you're doing port scanning. Then, if you want to identify the operating system, you can use, it also has a OS fingerprinting capability, which is a lot more accurate than it was before. Also, if you want to identify services that are running at the wrong ports, you can use version scans that give you the version of an application and also the port that it is running. And again, this is very helpful information. As soon as you get this picture, then you use vulnerability scan. So you can use Nessus, Nmap. These are two of the main tools in order to discover any vulnerabilities. Also, another technique is user enumeration, where you're recovering users and machines from the local network. And once you get this information, you can then use it in exploits later on. So basically, after you find some vulnerability, then you will be looking to exploit it. There are lots and lots of tools available. Metasploit is one of them. Core Impact, if you can afford it, it has really cool features. Nmap also has the Nmap scripting engine, which includes quite a lot of scripts and allow you to exploit vulnerabilities. But the important thing to understand in exploitation is the risks that it can carry. So it is really important during that time to be monitoring the health of the systems, during scanning and during exploitation, to make sure that no important services are affected. And so also in the planning and scoping phase, you need to define what is acceptable in this stage. For example, you don't want to reveal, if you're not allowed to use a sniffer to sniff the network, then you should be able to do that. And so there are quite a lot of risks, and you need to operate, you need to understand these risks and operate in that manner. Why it is important to exploit is obviously because just because you found a vulnerability, it doesn't mean that you are able to exploit it, that the exploit will work, and so on. So being able to do that is really important. And so you can use two basic types. You can have server-side exploits where you have these affect services, and usually there is one major exploit every year that is being exploited. Client-side affects client software, so Word, Excel, Acrobat, Java, QuickTime Player, and so on. They are one of the most widely used services. And so the idea is usually there is that you get, because you cannot connect to the client, you get the client to connect to you, deliver the exploit, and get them to be exploited in that way. So after access is gained, then the next step is to prove, first of all, that you gained access, usually getting a screenshot of the processes. If you've got access to a database or whatever, you get information about how many users were in that system. So you get some type of information to prove that you managed to get access. Also, usually the first point of access is used just as a starting point to go into other systems deeper within the network. And so what you do in that case is you look for any information that could be useful. So first of all, you can use the initial access point as a pivot point to go into other systems, to scan within the network now, within the firewall, to discover more systems, users, and so on. So you find any software that might be interesting, any system files, any passwords, Wi-Fi, pre-shared keys, for example, that you might want to use in other systems as well. All the systems, the particular system has been communicating with, say, in the local network or in general, so the DNS cache, R cache, and so on. So all of this information will be really useful in the following stages. So, okay, I mean, I provided a very rough overview of the different stages. The key point, really, apart from using the basic characteristics of the basic guidelines on securing systems, the key of this presentation really is to make you aware of the type of information that are publicly available information which can be used by penetration testing, but more importantly by attackers, in order to profile your organization. So you can do things, first of all, understanding metadata that might be present in documents of your organization, any information, sensitive information in job websites, in job adverts, any postings by your employees where they are discussing projects, code, and so on. Again, they could pose a risk, and we have seen how easy it is to just pull all of this information together. Also, ways of hardening systems to avoid revealing their identity is definitely very useful. There are already guidelines available, like the CIS security.org, which provides guidelines for hardening systems. There are also automated tools that help you to harden your systems. For example, MBSA for Windows, Bastille for Unix. If you want to go even further, you can use tools such as IP personality or server mask to change the IP personality of your system, so make a Windows system behave like a Unix system and so on. That it will definitely confuse attackers. And of course, using existing penetration testing tools to test the security of your systems will give you a lot of insights as to possible ways in which publicly available information can be exploited. Okay, and I will not go into social engineering and awareness raising, but this has been covered already, I think, to a great extent. And so, of course, raising the awareness of users would be really useful. So, thank you very much.